Hi there, my name is Paul. Today's lesson I'm going to be teaching you engineering science, which is part 1. So we're going to start with motion, power, and energy. And the motion is the action or a process of moving or being moved, which means that when we talk about motion, we talk about a body, it is in the displacement, it is in the movement that we say about a motion. So we're gonna look at these three ideas that describes the motion. The first one, we got the speed. A speed is a distance traveled per unit of time, and it is a scale quantity. So how do we get a speed? A speed is equal to distance over time. The second idea is velocity. A velocity is the rate of displacement undergone. So we have to underline this, undergone. We all get velocity when there's displacement undergone, which means the object, it is in the displacement per time in night. So we got two velocity. We got final velocity and we got initial velocity. What is the final velocity? The final velocity is a velocity that the car is moving with. The initial velocity is the velocity where the car starts with. So how do we get the velocity? A velocity is a displacement over time. So we'll understand well when we get an example. So let us look at this example that we got here. They say a car undergoes this, the line we spoke about here. A car undergoes a displacement of 600 meters during a period of 20 seconds. Now they ask you to calculate the average velocity of the car. So we got the displacement, which is given 600 meters, and we got time. It's 20 seconds. 20 seconds. So what they're asking us is to do the average velocity. So how do we get the velocity? As we say here, the velocity is a displacement over time. We got displacement, we got time. So what we're going to do, just to put the value, 600 over 20, and we get 30 meters per second. This is what they're asking us, the average velocity. Okay, let's go to another idea of movement, of motion. The third idea is acceleration. What is the acceleration? It's the rate at which the velocity change. Let's say you're driving a car. You're accelerating, so you're adding the speed on your car. So you're changing the velocity. It's the rate at which the velocity change that we call acceleration. Now, how do we get the acceleration? Well, acceleration equal to final velocity minus the initial velocity over time, where v is the final velocity, u is initial velocity, and t is a time. So let's go to an example of acceleration. A body accelerates uniformly in a straight line from 15 meters per second from 16 meters per second to 25 meters per second. So here we see two velocity, the initial velocity and the final velocity. During a period of 5 seconds, they give you the time. Now they're asking us to do, they say calculate the acceleration. We got the initial velocity, which is 15 meters per second, and we got final velocity, which is 25 meters per second, and they give us the time, which is 5 seconds. We are looking for acceleration. We know, then we come back here, acceleration is final velocity minus initial velocity over t. So what we're going to do is to put the value. We got the v, which is a final velocity, is 25, minus initial velocity is 15, all over 5. Then our acceleration was 2 meters per second squared. So this is how we get the acceleration. Now we're going over, and these are the summary of formulas that can help you to get acceleration, to get the velocity, to get a displacement, and these are the formula will help you. And I got some exercise to help you out to understand better. The first one, a body is at rest and it's accelerated at 0.8 meters per second squared in a straight line on a horizontal plane. Calculate the velocity after 7 seconds. So let's start. A body is at rest. When they say about a body is at rest, which means there is no movement at all. No movement at all. So the initial velocity is 0. Is accelerated at 0.8. This acceleration of the body is 0.8 meters per second squared. And now, in a straight line on a horizontal plane, okay, now calculate the velocity after 7 seconds. We got the time. Now what they ask you, the velocity. Now how do we get the velocity? We know the velocity is equal to displacement over time. Now in this case, we don't have displacement. We all have time. So we're gonna use the formula which says acceleration is equal to v minus u all over t, because we got acceleration, we don't have v, what we are looking, and our u is 0, our time is 7. So we're going to take our view out this side, and this will change the sign to be positive. So u plus acceleration time, then you get your answer. You put the value. Our u is 0, our acceleration is 0.8, our time is 7, and we get 5.6. This is our velocity. A second example, they said calculate the acceleration of a motor car. Calculate the acceleration of a motor car. If it is accelerated from 6, you understand, it accelerated from 6 meters per second. This is our initial velocity, to 15 meters per second. This is our final velocity during a period of 12 seconds, right? So it's quite simple. You need to understand the question. If you understand the question, you will get your answer very quickly. So let's say calculate acceleration of a motor. If it accelerates from, they give you the initial velocity, which is 6, and they give you the final velocity, which is 15, and they give you time. Now they're asking to calculate what? Acceleration. So how are we going to do it? We know the formula of our acceleration. Our acceleration is equal to final velocity minus initial velocity all over time. We got our final, which is 15 meters per second, minus u is 6, and over time is 12. Our answer is 0.75 meters per second square. This is our acceleration. Going to the next question. I hope you understand very well. It's quite easy. They said calculate the distance covered. Calculate the distance covered by an object if it is accelerated at 5 meters per second square from rest to 15 meters per second. Okay, there we go. What is given? It accelerated at, they give you your acceleration, which is 5 meters per second square. Our initial velocity here is 0 because they say from rest to, it's from rest to initial 0 to 15. This is our final velocity. So our final velocity. Now they're asking you to calculate the distance. We all know the distance is equal to v squared minus u squared over 2 acceleration. We got v, which is 15. We got u is 0. We got 2 and we got acceleration, which is 5. Then this is the answer. Thank you very much for watching. It would be nice if you subscribe for more videos. Thank you very much for watching.